everybody. This is Dan Stutterheim, CEO with Kasa Companies. I'm joined by Keith Blanding. He's the OEM Sales Manager for Rockwell Automation. He's a great partner of ours for all of our controls projects. Thought I would get with Keith and ask him a couple of questions regarding numerous topics. So the first question is, again, for lay people, if you had to explain what a PLC does to somebody outside of manufacturing, how would you describe that?
So I guess maybe we should start with what a PLC is and what PLC stands for. So PLC stands for Programmable Logic Controller, or in some cases, a lot of people call them PACs now, Programmable Automation Controller. The analogy I would use is the human body. So I want you to imagine yourself accidentally touching a hot stove. Don't do that, just imagine it. So a PLC is like your brain. It's constantly receiving these input signals, just like your brain, and it's trying to make sense of what's going on. So in this example, you've just touched the hot stove. Ouch. The PLC, your brain, just got some new inputs from some sensors. In this case, your eyes that just saw what happened, and the nerves in your body that sense the pain. So what happens next? Well, your brain uses logic to determine what happens next. In our case, that would be to pull your hand off the stove as quickly as possible. A PLC does the same thing. It runs program logic based on the inputs it's getting, and it decides the next logical thing to do. Okay, so now your brain knows you need to pull your hand away. So what's it going to do? It tells your muscles to move your hand, and probably your mouth to scream. Those are the outputs.
So Keith, why are PLCs, they're still the backbone of manufacturing automation? Even with all this new digital technology available today, they still are the backbone. Why is that?
The simple answer is that PLCs are still the backbone because they solve the hardest problem on automation better than anything else. And that's to be able to provide predictable, reliable, real-time control of whatever process it is that they're plugged into. So let me break that down. So a PLC is executing logic on a predictable time frame. That's the scan time of the program. These cloud systems that everyone loves nowadays, they're great, but they can't guarantee that timing. So if you need deterministic control, you need a PLC. So let's talk about real time. A cloud computing system, it's fighting the literal physics of data transmission. There's too much physical infrastructure between all of those cloud servers and the equipment on the plant floor. A PLC, on the other hand, is operating locally, and that local processing time is the only answer when, in some cases, milliseconds matter. And the last thing I would say is reliability. A PLC can run 24/7 for years, oftentimes in a really harsh plant environment. And look, I love my Windows laptop, but it was never designed to run a critical piece of equipment for a decade straight.
So what do you think the biggest misconception that people have about PLCs?
I think that they're still called PLCs. I like the term I like the term PAC, like I said, Programmable Automation Controller. So if you think about when the term PLC was kind of first being used in the 1980s and 1990s, controllers at that time, they were limited to sort of discrete on-off type control over these proprietary networks, and they didn't have a lot of memory, and they were kind of limited on the amount of data that they could handle. Well, today, PACs are what we call multidiscipline, so they can handle much more complex applications. They can do things like motion control, process control, high-speed data transmission. They can handle large tag databases and all these other things. So the name itself, PLC.
And this isn't just PLCs, but controls in general. When we're getting a system up and running and it's a critical stage, we're commissioning it, something will inevitably happen to where the system stops, it shuts down, it's not ready to go into production. And people will always come and point to the control system or the PLC logic and say, where's the problem, guys? Where is it? And what we tell them is, look, all we're doing is monitoring those inputs, that touching of a hot stove. If it's hot, we're pulling our hand away. So something out there must be hot. A lot of times that's not good enough. They say, no, it's your problem. And the joke in the industry is it's a mechanical problem, not a controls problem. So it's a misconception.
Absolutely. And you know as well as I do that it's really, really hard to program around a mechanical issue.
Bingo.
I've tried, but it's really hard.